we decided that what we're going to have to rely on is the good coffee brew back there. A warm welcome for Pete Mazur.
Pass the mic. Yes, I see that. You can tell I'm an action fitter. All right. I'm Pete Mazur, and what we're going to talk about today is action fitting on vintage American shotguns. All right, it's showtime, folks. So, without further ado, the way we want to start is to go through some of the terms that we're going to be using when we're talking about our guns. And what I've put on the blackboard there is a rough outline of what we're going to talk about today. So, we start out with our terms, and we always like to start with the action. And let me see, I guess we'll use this old gun here. This is LeFevre, by the way. It's what we call a side plate LeFevre. Okay, we start, we talk about breech face. Okay, on any double gun, this is your breech face. This is where the barrels meet up. This is where where everything happens, where your firing pins come out. Second are the fences. All right, here's our breech. Take a little pointer here. Here's the breech face. The fences are the material right behind the breeches. Okay, the bar. All right, this is the bar of the action right here. When you talk about a side lock, we have a bar action side lock and a back action side lock, and what we're talking about is like part of the mechanism is in the bar right in here. Okay, water table. The water table is on top of the bar. Okay, the knuckle joint is your joint right where the action and fore-end iron come together. That's your knuckle joint. All right, locking bolt. On LeFevre, we got a silly little locking bolt up here on the top that's hooked up to the top lever. On a Parker, it's a more standard type of a locking bolt. You have your top lever up here, and get a pointer. And down inside, you have a square locking bolt. That little square locking bolt looks just like that. And it's a standard wedge, what they would call standard wedge pass locking bolt. Okay, top lever. That's standard. That's what operates your locking mechanism. In older guns, they used to have side levers, so they would take this lever and they'd put it on the side of the gun. Some of them hinge it underneath, but normally, what we're dealing with is top levers. For American guns, they always use a top lever. Okay, get to the barrels. Here's a set of LC Smith barrels, slightly short. Okay, that's your breech. Then we have the flats. Okay, these are the flats of the barrels. What those flats do, if you take on this LeFevre, you got your flats. They mate up with the water table. Okay, then you have the lumps. The lumps, that's an English term, and these are all English terms. And I like to use English terms because they're basically universal terms. Okay, these are the lumps. In America, we tend to call them lugs, but the proper terminology is lumps. Sometimes you have one lump, sometimes you have two, sometimes many as three. Okay, next, yes?
A foreign attachment point, would that be also a foreign loop?
No, that's a loop.
Okay.
Okay, that's just right here. The reason why it's called a loop is that is a term from muzzleloading. They used to have on muzzleloading guns, you literally had a loop and you had a wedge. The English said, we're not going to come up with another concept, we're going to call this a loop. And that's it, guys. Okay, barrel extension. Barrel extensions are, and there's a lot of them on American guns, that's this extension coming out the back in the breech area. Okay, you got it on LeFevre's. It's very pronounced on Foxes and LC Smiths. In fact, there's your barrel extension again. And it has a locking surface. All right, last one's fore-end iron. There really not a whole lot of comments about fore-end iron, other than there it is. And that's your knuckle joint again. Okay.
You missed the repeat it?
The hook. Oh my God, I missed the hook. The hook. I missed the hook. Okay, thank you. Okay, this is, well, on a LeFevre, there's no hook. The hook. Okay. What we're going to do then is we'll change. We got a hook. So that's this joint, that's this well, hook part on the lump. What that engages is the hinge pin, which, in fact, that's, by God, I should have said that. The hinge pin on the action. On all your action, well, your Parkers and Foxes and LC Smiths, they have a hinge pin. This is a Fox, little Fox Sterlingworth. This is the hinge pin, slides right in there. And this hook engages on that pin. That's what it rides on when you open the gun. Okay. Like only I need you to help me along. Okay. Start off with check for looseness. Okay. Normally, everybody tells you have the gun together. Let me see. Do we have this gun together? Huh. Not good. Got it together. Success. A lot of fellows will tell you the only way to check for looseness is to rattle a gun. And I think you can, by golly, you should be able to rattle that gun and hear it. It's a loose gun. Anyway, what they'll tell you is you simply take the gun from the butt and you can rattle it. There we go. Sounds like a castanet. All right, that's a good start. The problem is there are lots of ways to tighten up a gun that are cheap and dirty by using this 4-end iron. So what you want to do is you always take your 4-end iron off and then you rattle it. Worse yet. Okay. Now, there are different kinds of looseness. We have one for locking bolts. Okay, on a locking bolt, the concept is to pull the barrels down on our water table and have the flats come right nice and tight together. So it's an up and down movement. One way to check would simply be to take your barrels, put it on the side of the bench, and you can rattle it, move that up and rattle the action. And you can actually move it up and down. On this, you can actually feel that action move up and down. If you happen to be at your shop, you can stick your barrels in a padded vise, you can rattle it, and you can feel it moving up and down. That's your up and down movement is primarily going to be your locking bolt if that's going to be loose. Okay. Next is off the face, and that's the real nasty one. When we're talking about off the face, let me see, here we go. Little poor old Sterlingworth here. That's a dramatic off the face. Here we go, here's our breeches, here's the face of our breech, and that is, there's a big gap in there. What you want to do is you want to reduce that gap. Like that, real nice and tight. Okay. To find off the face, and one of the best ways that I know, and to describe it, is you can open your barrels up and put a shim in there and close your barrels. If you can close the barrels and move the top lever over with a shim, obviously there's going to be a space between the breech face and the barrels. So, and that is that is the most critical when we're talking about the tightening up a gun.
When it's come off the face, why does it come off the face?
I'll tell you that a little later. Well, okay, we'll answer that right now. You can have, primarily, it's simply from shooting the gun, okay? If you shoot a really hot load, you have a lot of pressure, and it's going to want to pull this joint apart, okay? If you have an older gun, you don't even have to really shoot hot loads. If you shoot this gun a lot, I mean, you get a gun in that's 100 years old, and the man's been shooting the right barrel a lot, you actually can see that the right barrel's pushed forward, and the left barrel's hanging in there.
Has the barrel moved in the assembly, or has it twist on the lump, or what has happened?
Okay. One of the things that's happened is
Could you address the question to the
Oh,
if we use
okay.
it.
All right. Yeah, the question was, why are we getting the barrels off the face? One reason, which would be simple enough, is that you've gotten wear on this, on your hinge pin. I mean, the simple fact of that barrel moving up and down, you simply can just wear it out. The other thing that can happen is that well, several other things can happen. The actual breech faces, they can actually literally be pushed back if you're shooting really hot loads. And again, those barrels can be shoved forward a little bit with really hot loads. So there's a lot of forces involved here. And if we went to that seminar about materials sciences, we know, well, they have a fatigue factor. When the gun is all new, it will hold the pressures. As the years go by, of constant hammering, it just simply starts to loosen up. And if you've built the gun properly, you've built it so stout, as the English would say, that you're going to compensate for this fatigue factor. One of the problems with the gentry over in England wanting finer and lighter guns is the fact that they started lightening up all these surfaces, and you started having problems of the guns coming apart. And that was just simply the nature of the beast in the design. Does that answer your question? Okay. All right, knuckle joint. When we talk about the knuckle joint being loose, this is an area that you talk to a lot of old timers and they'll say, they'll grab the gun and they'll kind of rattle around and say, that's a nice stout gun, and they'll open the barrels, and then they rattle around and say, oh, that's a loose gun. And a lot of your clients don't like the barrels loose flopping around when the gun is open. That's strictly knuckle joint problem. And I'll just tell you how to correct that problem right now, because it's a relatively simple procedure. What you're trying to do when you open this knuckle joint has got a pretzel grip between the barrels. Okay. Let me see. Use this for explanation. See, we've got a loop, and we've got a fore-end iron. It's got a window in here. And that window will fall that window will be trapped between the back of the loop and the face of your knuckle. And I get the pretzel hold, and that holds those barrels nice and snug so that when you open the gun, the barrels still stay snug. Okay? If you want to tighten up that joint, you've got to spread something apart. What you do, and what was common in the factories, very common, is that they give it a whack. They spread that out. In this case, this is a Fox Sterlingworth, and it's a little bit different design, but by golly, if you look real closely, there's a big old punch mark right here, right across that. And then they're actually stretching that metal apart. And that's going to, again, give a pretzel hold. On your LeFevres, they were known for the 13 points of compensation. If you look real closely, what they did is they built in a little extra, they added an extra piece to the back of this loop so that they could open that up, again, to get your pretzel hold and tighten up that joint. Now, you can, if you want, if you don't want to, if you got your purdy there, you don't want to smack it, you can also weld up that surface area. And you can weld up the back working on the iron. You never really want to work on your barrels, because your iron's a whole lot easier to work on. So you can either stretch that metal, or you can weld on it and refit it. But you want to get a good snug fit. If you look at a real new gun, especially an English gun in the white, and I'll open the top lever and start to open the gun, gosh, you almost have to put it over your leg. Merkels are notorious for this. A brand new Merkel, you open it up, you try to open it, it's really snug. They've got that knuckle joint really nice and tight. That's all it is. That's what it's all about. And if your customer doesn't like that, then you might have to open up the joint a little bit. Just take a tiny bit of material off of this back of that loop, and that'll loosen that gun up so that the fellow can open it up if he wants. Because I remember I had a Merkel skeet gun, and everybody used to laugh at me because I'd open it over my knee. Okay. We've got our looseness down. And now we're going to go to the different kind of locking bolts. And by golly, you got me trapped. Okay, these different concepts are strictly Mazur's concepts. They aren't in steel. Okay, we have a locking bolt. We have what I consider an adjustable type of locking bolt. And in an adjustable locking bolt, again, we come back to our wonderful Dan LeFevre. Our top lever is our locking system. They've got some little adjustments there so that you can actually adjust that top lever, and so that locking surface will come further forward on this locking surface. And because they're both at an incline, as that incline gets tighter, you pull your barrels down. Model 21s, sure enough, they are adjustable. And the way they're adjustable is you have your top lever, okay, it looks sort of, it's kind of like a Parker system. You've got a top lever and an underbolt, which is moving down here. And what they've done, the clever little guys, is they didn't mess with any of the locking surface, the locking bolt. What they did is they've got, let me see, do I have a, no, I guess I don't have one like that. Okay. And on a 21, you'll have a cut in this area, which that locking bolt fits into. You're also going to have, if you look real carefully, a screw, the head of a screw, drill right in there. It's drilled and tapped and sitting there. What that screw does, when the gun is at first brand new, that screw is backed all the way out, so that locking bolt can't engage fully. They fit it up that way. Then as the gun starts to wear, you screw that screw in deeper, and that locking bolt comes closer. And those two angled surfaces come tighter and pull those barrels down. So that as that gun wears, you just keep moving that screw in, and that locking bolt just keeps holding it down. So you literally can't adjust it. That's an adjustable locking surface. All right, Ithacas. I don't have to have an Ithaca up here. On the older Flues models, they had a system of linkage, as they put it. And get that, there we go. And on theirs, it was a rather clever system. You had your top lever up here. Then you had a little bar that came down, and in this bar was your locking bolt. Okay, your locking bolt got a little angled surface on it. This bar turns out is a square. There's a hole in it. This locking bolt, the guys, this is a machine-made gun. The simplest way to make a locking bolt is to make it turn like cylinder, just like this piece of chalk. Okay. In this window, this little that has the linkage, you've got a little set screw. That set screw holds on to that your locking bolt. You just, well, in this case, the owner of the gun couldn't do it. You have to go to your gun maker, but your gun maker comes in, pulls the gun apart, undoes the set screw, shoves your little locking bolt a little bit further forward, pulls your barrels back down. And that was their concept. It worked very well, actually. Clever little Ithaca guys. Okay. The Flues model, by the way, was your very first Ithacas. They went to a Rotary Bolt later, and I believe their latest model that they called a LeFevre had, again, this linkage system. All right, next we get to what I would call a compensating bolting system. And this is basically based around the Baker pattern. L.C. Smith bought the Baker pattern, and what we're talking about here is a rotary bolt. And a rotary bolt looks just like it's a cylinder. And what we're doing here is we've got, if you look at it from the front, you've got a cylinder, and you've got part of this cut away. Okay, this cylinder moves in this direction. As this cylinder comes around, it engages. Well, this is a Fox, and this is a L.C. Smith, so they aren't going to engage. Anyway, it engages your little window on your barrel extension. And that window has an incline in it. And when we have two inclines, as you pull it together, you pull your barrels back down. So this one's self-compensating. As that wears, it just keeps on moving all around in your arc. And personally, I've never seen an LC Smith that was loose in the sense that when the locking bolt is locked up, those barrels are down tight, and you generally can shoot it. Same with Foxes. It is seems a little bizarre, but a system as far as if you're comparing it to your best grade guns, but by golly, it works and works very well. The Ithacas, the NID models, they're new. I believe NID is anyway. That was what they called it. Their new model after 100,000. New Ithaca doubles. Thank you. They incorporated the rotary bolt system. So you have 3 guns with rotary bolt systems, and by golly, they worked. I mean, when you open the guns up, yeah, they may be loose and they model around, but when everything was snugged up, it was tight. Now, this rotary system, though, isn't going to help you if the barrels are off the face, but it will lock the barrel down to that water table. All right.
Doesn't that bolt, doesn't it pull the barrel in as well as down?
It does, but there are plenty of Ithacas and an LC Smiths with barrels off the face. In fact, most of them are. It's a good system, but not really that good. One of the problems is that this rotary bolt, oops, let me step on it here. This rotary bolt, it sits in the gun here. You got the top lever up here. Then, oops, wait a minute, behind it. Sorry, top lever's here. Oh, wait a minute. No, I'm going to confuse me. Okay. One of the problems, especially on an LC Smith, for example, you have, oops, there we go. Top lever. You got a shaft, the top lever. You've got a little part here, looks like a little box, a little arm sticking out, and that is coupler. Okay, there is no real link up on this rotary bolt that's pulling per se. Now the cuts in the action keep that rotary bolt in place, but there's no really. The fits just are. It's a machine-made gun, so you just can't get the fit so it's really pulling backwards that well. It does, and as you pointed out, which is an excellent point, there is an angle on here. This is not just a square and it's not parallel. They have designed it so it pulls not only down but back. However, it's a great concept, but in practice, the barrels can come off the face fairly easily. And I've measured them, and it's not unusual to have barrel off face 20,000 or so.
Well, yeah, that was going to be my next question. Is can you modify that? Can you? There are 2 planes. There are 2 wedges on that bolt. One pulls the barrels in, and one pushes them down.
Yeah.
And I was going to ask you, can you build up that surface on the bolt in such a way to pull the barrels back into the standing reach?
Well, I've tried that, and in theory, it's a great theory. In practice, put a new hinge pin. What we have to realize, we're talking with. A lot of us are rifle makers, and we say 50,000 psi, and we can relate to that, and that's a lot of pressure. And then we say 15,000 psi for pressures on a shotgun. We say, gee, that's not much. We make it sound like you can kind of hold the cartridge in your hand when it goes off, but it isn't. Let's face it, 1,000 pounds psi is a big problem. So the amount of pressures involved are much greater. A lot of times, much greater than physical locking surfaces. If you have a gun, a lot of your, for example, your not English, but your European makers, especially the Spanish guns, they like to say that they got 4 locking bolts or 3 locking bolts, and everybody says, ooh, isn't that wonderful? Well, if that locking bolt isn't properly fit, it just beats itself to death. You can have all the locking bolts you want. I'd much rather have one good stout one that's properly fit, and that's going to hold that barrel down far better than 3 or 4 that are just improperly designed or improperly fit. A lot of the, in fact, everything on double guns, whether they be American or English or European, doesn't matter. You not only have to have good design, but then you have to follow through and have a good fit. If you don't have a good fit, it doesn't matter. You can have a copy of a Purdy and it shoots loose in 5 minutes. If you don't have good heat treatment, the gun will shoot loose in 5 minutes. So it's all interrelated, and we've got a lot more pressure than we realize. Does that answer your question?
Yes.
Great. Okay. And now we come back to the standard underbolt. A lot of the English terminology, what they would call it a wedge fast system. All right. The best example of that is a Parker. And on the Parker, you've got a top lever up here. And good old Parker, they always put 6 parts. If they can do it with 6 parts instead of 2, they'll fit 6 parts in there. They've got a rather intricate little coupling system here, and then back down inside the action between the around in the water table there, below the water table. You've got a little square bolt, which again we say looks like yay. It looks all rectangular and square. This area here is for the linkage on the back end. If you flip the bolt over, you find that yes, you've got again an angled surface here. What we want is 2 angled surfaces to draw the barrels down. On the older guns, when they got loose, you had to put a new locking bolt in. And this, ironically, that's the real thing. That's an original unfitted locking bolt. I don't know, I'm going to keep that for posterity. Naturally, you're not going to go down to your local hardware store and buy a brand new locking bolt. So what I would recommend is you can add some weld to the bottom surface, to that locking surface. Some fellows, if they're don't feel comfortable with welding, I have done it where you ground the surface away a little bit, get a hardened piece of steel and silver braze, a hardened piece of steel, that will hold those barrels down. Okay, what else? Well, we weld up the locking bolt and we put we can make one. And now in making a locking bolt, you'll notice, well, you can't see it from here, but I can see it. This is case hardened. Rather nice case hardened, case colors on it. What they've done is they've taken a soft piece of steel and they case hardened it. And the reason why they did that is that with a soft piece of steel, you have a soft body internally and that'll take all the repeated shootings, because every time you shoot it, we've got motion, we got fracture, we got movement inside there, and that soft that soft steel is going to withstand that without cracking. Then you have a hard surface on the outside, and that's what's going to keep those barrels down, and it's also going to make that locking bolt move back and forth well. So you're better off using a case hardenable steel rather than coming along with a high-tech steel that's hardened all the way through, that may work very well, but eventually may end up with a fracture in that locking bolt. As Parker kept improving their guns, what they did do, which was a wonderful thing, is they came up with what they call a barrel plate, or a bolt plate actually. And what they did is they went up to our barrels on a Parker, the back end, come down, come out like this, and down, and that's the back barrels are up here. Okay, this is the back of this is the lump, and we've got a locking surface here. We've got a locking bolt here, which is square, and we've got an angle here. Okay, this is the area we're talking about. That's what locks those barrels down. What those clever fellows did is in this surface, they put in a T, or this locking plate. It looks from the front, it literally looks like a T. And they slotted this surface, and you have a little pin here. You just knock your pin out, put a new locking plate in there, and that pulls everything back together again. Works out real well. Great system for a change. Okay. Yes.
Assuming you can't get those locking plates anymore as a part.
Well, you can. Matter of fact, you can get them from the Parker Reproduction people. Now, if you can't, you can make it up. In that case, I've used tool steel, hardened it up, and I draw it back to the straw. And that works really well. Okay. All right. that if you're going to start working on locking bolts is this angle in here. Extremely critical. Extremely critical. What you want to do is you want to match the original angle on your locking bolt and the original angle on this locking surface, because what they're set up so that they're angled, but they are both at the same angle. If you change this angle a little bit, you get a wedging system. When you get a wedging system, I guarantee you, when you fire that gun, you will need a very large mallet to open that gun. They will wedge themselves in there super tight. So if you ever come along and you want to make a locking bolt, or you want to make one of these locking bolt plates, make sure that you get those angles set up properly. And it's quite critical, because the first time you make one, boy, it's really hard to pop them apart. And then as you learn, you'll get to the point where you make it and it's almost right, and it wedges up, and you pop your top lever open, and you go in there and just adjust it a little bit. One thing I like to do with these surfaces is I like to stone them so that it's nice and slick. And by the way, if your angles are wrong, even if you stone that slick, it's going to wedge fast. I mean, wedge fast. The other thing I like to do is after I stone it, I burnish it. And this is an older terminology, and the way I burnish things, and whether this is my concept of burnishing, is I just simply put a drop of oil on the surface I want to burnish. I have a real hard piece of steel, usually like an old file, that I've ground down. I've highly polished that ground surface. I have a real hard, slick surface, and I just put my part in my vise and I lean on it as hard as I can. I just sort of like I'm kind of just mashing. I think in terms of mashing the molecules over and closing the pores of the steel. And in fact, if you read a lot of the old accounts, they talked about closing the pores of the steel, and you create this very slick surface. You can actually feel it. You can take a surface that isn't burnished and kind of feel it, and it feels okay, and it's smooth, but you feel a burnished surface and it feels slick, almost as if you put Teflon on it. Works quite well. Okay. All right. We've got our different locking surfaces, and now here's this. I'm going to give you a comment on LC Smiths and Foxes and their compensating locking bolt. This happened to me at the beginning of this year. There have been times when I got an LC Smith in with this compensating rotary locking bolt that never fails, that failed. Generally what has happened is your locking bolt cracks in through this area. They are case hardened. I have had some success welding them up, and I've talked to Dennis Potter, who's another guild member, and he came up with a clever system of brazing, and he said it worked quite well for him. Now, I got an LC Smith in a real nice one. It was a crown grade featherweight, and the man had just bought it, and he sent it out to me. He said, every time I fire the gun, it opens, automatic opener. And I just assumed that he had a cracked locking bolt. I said, not to worry. So I get it in, pull it all apart, the locking bolt's fine. Hey, what's going on? And then I started checking things. So the first thing I did, I checked the top lever spring. Top lever spring awfully loose. I said, aha! Put in a heavier locking, top lever spring. And that top lever spring keeps that rotary bolt really nice and snug. Went out and shot it with a light load. Sure enough, it opened up. Okay, that's number one. Okay. Number two. I said, I got it now. My problem is, I've got this locking surface up here in my barrel extension. Didn't look really good. I welded that up, refit it. Bang. It worked with a light load and not with a heavy load. Okay. Okay, number three. I came along and I said, there's something wrong with this locking bolt. And I tried replacing it. Unless you have a brand new locking bolt that's unfit, you start swapping locking bolts, no go. So I had to live with that locking bolt. Okay. Number four. I came along and I said, I measured my distance between the barrels and my breech face, and by golly, those barrels are off the face. It must be the barrels are off the face. Must be. So I went out to the range and I said, I'm going to be smart. I put some shims in this, in the knuckle joint between the hook and our hinge pin. Closed the gun up carefully, fired the gun. Yep, it works great with light loads. Fired some more. Thing popped loose a little bit with heavy loads. I said, my shims have slipped. I know, call the customer up. And I said, new hinge pin. Okay, number 5. I replaced the hinge pin. Went in there, magnificent job. Had it all engraved, tightened that sucker up. Well, I was ready to go. Went out to the range, bang, 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 bang. Worked quite well, but he wanted to shoot some really heavy loads in it. Bought some real heavy loads, bang, 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 whoops, opened up. Aha, what do I do now, folks? Came back to the shop and measured up my chambers, number 6. Checked my chambers, they're a little small. Well, I know, I called the customer back up and said, we're going to put long forcing cones in this thing, and it's going to reduce the pressures, and everything's going to be great. Went back out to the range, works with light loads, works with heavy loads, tried it to 2 3/4 inch Magnum, poof, valve opener. Okay, finally, number 7. I'm rather distraught by now. Customer's rather distraught by now, too.
Bro.
Yeah. I'm standing around, I've got several LC Smiths in my shop, and I'm looking around at LC Smiths, and saying to myself, what the hell's going on here? Come on, guys. Okay. And I happen to be looking through Brophy's book, I'm saying to myself, I'm going to make a brand new locking bolt. And I look at this drawing, and the drawing has a wonderful little arc right here. Okay. And I happen to be pulling apart locking bolts and looking at them under a glass. I say, gee, the ones that I see have something like here. I mean, we're talking 10,000, maybe 15,000 at the most. There's a little whoopie-doo right there. That's strange. I pulled the locking bolt out of my wonderful crown grate, and I looked there. There's no little whoopie-doo. Son of a gun. What I've got is an unfit locking bolt. That locking bolt had never been fit for that gun. Somebody had worked on that gun, popped this brand new locking bolt in there, never fit it. Well, let me tell you, I went there, 3 swipes for the file, zip, 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 made me this little hook. Bang! 2 3/4 inch short magnums, 3 inch magnums, that sucker, it is tight. It's incredible. What was happening was if you don't have a slight relief there, the locking, that rotary bolt doesn't allow it to do what it's supposed to do. It doesn't go up over center. It wasn't going over center. Every time you fired it, no matter how much pressure you had on it, it just kicked that rotary bolt back at you. So if you ever have a problem with an LC Smith, first thing you do is check to see if the thing was set up properly. Because I mean, I had LC Smiths in the shop with 20 thousandths off the face, the thing would rattle. You could put a short magnum in there and fire it. And sure enough, you look at it, by golly, there's that little hook. So the customer was satisfied in the end. I have the whiplashes to prove it too. Okay. Next we come to the real killer. That's barrels off the face. Or as the English say, barrels off the face. Okay. We're going to digress just a little bit. And Climber, the ring manufacturer, makes a Headspace Ring. Brownell sells it. In their literature, they say you can use this if your barrels are off the face because it takes up the headspace. It's a great idea, and I guess that's okay if you want to have this hunk of steel sticking out. Well, see what you're doing. In fact, I happen to have a Climber Headspace Ring, and I've got my breeches. What you're doing here is you're reaming out the back of that chamber. You're sliding this little ring in here, and if you really had a barrel that's off the face, obviously your real little ring's going to be sticking back up there. It looks a little corny as far as I'm concerned. But what they're really saying is that you would actually come along in this Headspace Ring, you would actually use a header tool looks like this, slides in. Okay, that heading tool, well, the English call it a heading tool, we would probably call it a rim cutter. And what you're doing is you're actually creating a new rim back in your chambers. And you're setting your cartridges back so that those cartridges come right up against the breech face and you've corrected your headspace. And again, it's a nice idea. And if you're working on Stevens, that's okay. My personal feeling about it is this, if I have a barrels that are off the face and we're talking a good gun, I'm going to put a new hinge pin in it. And that's it, because that's the proper repair. Okay. However, the main reason why I brought this up, this is a wonderful device for sticking firing pins. Okay? What happens is the Europeans, their dimensions, it turns out their dimensions for a rim cut are deeper than American dimensions. I just had a problem with a Parker this way. The Parker had been retubed by Wesley Richards. Did a great job. Cut the rims in a little bit deep. And if you have a combination of the rim cut being a little deep, and now we're using American shot shells, which are a lot hotter, you're going to end up with a real headspace problem in there. And your primer's going to want to back out, and your firing pin's going to stick in there, and it's going to be hard to open. You're going to have the firing pin's going to be trapped in there every doggone time. That's when this little headspace ring is a wonderful thing. You can just properly headspace that, assuming your barrels are on the face again. Another area where this can be very, very useful is if you have an over and under. We have to remember our barrels are side by side. Our arc is going to be relatively small. Flip these over, our arc is going to be quite large. It's going to be quite dramatic for this barrel in particular. If you've got an over and under, and the customer is saying, gee whiz, the bottom barrel doesn't fire all the time, or what you want to be able to correct that. You want to be able to bring that headspace out so that firing pin will hit and fire. So that climber headspace ring used in the proper areas is a wonderful device. Okay. Now we get to replacing the hinge pin. On replacing the hinge pin, I've pulled my barrels back as much as 15 thousandths on a breech face. Let me see. Get a breech face here. And we pull our barrels back in there as much as 15 thousandths. I'm no expert, but my feeling is that 15 thousandths is about your maximum. Because what happens when you start bringing those barrels back more than 15 thousandths, you create other problems. Like on a Parker, you've got a dull's head extension on your barrel. Your dull's head extension looks like this, very similar on this LeFevre to that Parker. This dull's head extension starts moving back into the receiver, and it starts hitting the receiver. You start creating more problems. So I would say 15 thousandths is max. I would rather try to pull my barrels back 10. When you do bring those back, you can, when you're involved in fooling around with setting your barrels back, you can at the same time clean up the breech face if you have pitting. But what is important is that the amount of movement you're bringing back, 5 or 10 thousandths is quite a bit. You can do an awful lot with that amount of movement in those barrels. It doesn't sound like much, but when you start fitting it, when you move those barrels back 10 or 15 thousandths, you've done a lot, an awful lot. Okay. Next thing is when you do set these surfaces back, you're not just setting this barrel straight back and refitting this hook. All the surfaces, everything involved in this barrel has changed. You have to refit your barrel extension a little bit. You have to make sure that iron fits properly. Sometimes you have to adjust it so that the barrel comes back down on the water table. The flats in the barrel table are coming back properly. It's very involved. When I first started this 10 years ago, I was talking to Jack Rowe. He's been very nice to me. He's an English gun maker. He lives in Enid, Oklahoma. And he comes along, and we discussed setting the barrels back. And off I went, merrily setting my barrels back. And after about 8 or 9 hours of work, I called up Jack and says, my God, Jack, what am I doing wrong? And says, mate, patience, mate, patience. Take your time. Be very careful. Get in there with your little needle flies. Work at it, work at it. Sure enough, 15 hours later, Jack, success. I made it. 10 years go by, and another gun maker comes along. In the guild, I see him now. He works on boxes, and he calls Pete up and he says, Pete, what am I doing wrong? I worked on this for 6 hours. What do I do? Patience, mate, patience. It takes time. If you're going to do the job right, it's incredible. I have that, yes?
Jack also says it helps if you have 2 pairs of eyes.
True, absolutely. That does help if you have 2 pairs of eyes. That 8-bore I had on my table, that big gun, when it was color hardened, it warped a little bit. Nothing wrong with that. Warpage comes with the territory when it's color hardening. It only took me 15 hours to get those barrels locking up the way they're supposed to. I was very proud of that. I went and I showed everybody, look how that snaps back together again. By golly, boy, I was hot. I thought I was almost good. I almost called myself an actioner, but I won't do that. But it takes a lot of time. So be prepared when you start involved in a hinge pin. This is not something that's easy. If you do it sloppy, yeah, you can do it sloppy, but you haven't done much. It'll shoot loose again. Okay. We start down our list of guns again. On LeFevre's have an adjustment. Sure enough, old Uncle Dan was a pretty smart fellow. Instead of, in this knuckle joint, instead of having a pin, he came along. But it's like a knuckle joint or a bushing, and it's a big old screw, and it's got a rounded surface on it. And that screw fits in to a rounded surface up here, in the front of that lump. So, if that screw, if that's a threaded part, all you got to do is take a big screwdriver and torque it in just a little bit and pull those barrels right up. I guarantee you need a big screwdriver. Most of these guns are 100 years old. They've been sitting around for a long time. You got to really be careful and torque it in. But the LeFevre's the only gun that I know of, well, the only American gun, that you can literally adjust that hinge pin and pull those barrels back. Okay, on a Parker, again, good old Parker, instead of using one part, they use 6. All right. They don't have just a hinge pin. They have a joint roll. What they've got is they've got a screw on one side, and they got a sleeve on the other side, and that sleeve fits through something that's called a joint roll. Like, yeah, don't ask me why they did that. That's what they did. Fortunately, the gun parts company has joint rolls, and the Parker reproduction people have joint rolls. So if your barrels are off the face, you can take that apart and put a new joint roll in. There was a time when you couldn't get these. Some fellows would hard comb them and bring them back, put their 4th out. That works quite well. When you get in your mind that you're going to take one of these things apart, get you a big screwdriver. These are very fine threads. There's lots of them. It's been in there for a long time. When the guys set them up, they had guys with arms this big, and they torqued that down. You got to have arms this big to get that apart. And you also have to remember that little screw slot's running lengthwise. You'll sit there and you'll torque it down, and it'll be off a little bit, and then you'll torque it down some more, and it'll be off a little. And then you get a big cheater bar, and your neighbor, and you can torque it down some more, and you'll finally get it down. It's a lot of pressure on that. So you can use a joint roll on these things. Okay, L.C. Smiths. And we're going to get a little more involved with L.C. Smiths, because L.C.'s, yes?
Parkers, do the joint rolls wear, or do
the pin?
The lumps wear?
Okay.
And do the joint rolls come in different sizes?
I don't know whether they come in different sizes. Normally, your joint rolls what's wearing. Actually, both surfaces are going to wear, but your joint roll is replaceable, and that's what you do. And if you put a new one in, normally that's enough to take it up. Again, we're talking about thousandths of an inch. 5 thousandths of an inch is a lot when you're talking about the 2 parts joint, when we're talking about lockup. Okay. On an L.C. Smith and Fox, let me see, we got Fox and L.C. Smith and Ithaca. They're all about the same. What we have is a hole through the knuckle here, right up near the knuckle joint, and we've got a pin. And it's a tapered pin. It goes in only on one side. That's the wrong side. Fall off. Get it all jammed up now. Slides in there. Okay. On a Fox, you've got 2 dowel pins coming in from the front. That holds that pin in. On an LC Smith, you got 2 dowel pins coming from the top. And on an Ithaca, I get 2 dowel pins coming in from the top. You got to remove the dowel pins and pull your pin out. We'll get a little more involved in this as soon as I finish up just about the pins themselves. What we'll do is tell you how to put a new hinge pin in on an LC Smith. Okay. On 21 Winchester, what they've done is a similar concept to a Parker with their joint roll. They've got a screw up here, and they've got a little cylinder. And you take your screw out, and out pops the hinge pin, which turns out to be a cylinder. You cannot get parts for Winchester 21s. That cylinder is relatively simple to make. You just simply make another cylinder, put it in there, and tighten everything up. If you have to have an oversized cylinder on a 21, there is not a whole lot of space because of the hole actually that's been bored into the action. So, boy, not much. You can't get a pin. You can't get a new hinge pin in there that's much more than about 5 thousandths oversized, because then you're going to end up having to modify your receiver, and life becomes real difficult. However, if you talk to old Oliver Winchester, he'll say, well, they don't shoot loose anyway, so you don't have to worry about this. But on that rare occasion, you may have to do that. Okay. Now, coming down to the wire here with an LC Smith. Okay. First thing you do, you got to remove your dowel pins. When we set our dowel pins, are up here on top of the knuckle. Those dowel pins are 95 thousandths. Come in, drill and tap, you drill them out. The dowel pins actually go further down through into the hinge pin area. But all you really need to do is drill them out to the top of that surface, because all you're trying to do is knock that hinge and knock your hinge pin out. Once you've broken that joint, you just pop it out. But so you drill out your 2 dowel pins. If you can't remember left to right as far as which way that taper is, all you do is just take a micrometer or your calipers. You can measure on either side of that hinge pin, and there's enough of it. It's a rather steep taper, and one side will be larger diameter than the other. Obviously, you're going to hit the small side, so the big side goes out the gun. Okay. Now, your new pin, you can either make those. It happens to be a number 7 taper. You can go down to your machine shop and buy a hinge pin. Or you can go to the gun parts company and they've got hinge pins. Your hinge pin is going to be soft, and it's going to be case hardened. On LC Smiths, they put everything together and they case harden the entire action and the hinge pin all at one time. And on most guns you're going to be working, if you're going to do a restoration, you put everything together and you quench it. If you have to, if you're just doing a repair, you're going to have to fit up that hinge pin, get it all completely fit, and case harden it, drive it in, and then put your dowel pins in. That's a little tricky, but it can be done. Okay.
Are those dowel pins threaded, or are they?
No, just a dowel pin.
And they're just press fit in?
Yeah, and they're just soft steel. You can drill them quite easily, actually. All right. You've removed your hinge pin. You've driven your new hinge pin in. What I like to do is I like to put my barrels on the gun a little bit, and I drive my hinge pin in. You don't want to drive that hinge pin in real tight, because then you'll lock those barrels in there. You'll never get them apart. But you drive your hinge pin in enough so that you set your barrels back so they're kissing the face a little bit. What I like to do then is I take my barrels off. I move my hinge pin in a little bit further. That way I've taken up, and that way I know I'm going to end up with a good fit. If you hit it too hard, really pop it in there naturally, you're just really creating more work for yourself than is necessary. All right. On fitting it up, first thing you're going to fit is the hook, which is this part right here. First thing you do is you put your barrels on your hinge pin, and you want 100% contact if you can get it. That's mighty good. You get really good, that good of contact. But first you want to get your hook fitted to your hinge pin. What I do is I start out with a file, but what I've found works very, very well is a scraper. Works marvelously. I've got this little 3-cornered scraper, and what I'm doing is I've got my hook here. If I want to take some material out, I black up or smoke my joint, and I find my high spot, and I come in with my and I scrape this way. Now my 3-corner is going like this. I'm scraping in this direction. And surprise, surprise, if you've got that scraper really nice and sharp, the steel on your hook is not, it's not hardenable tool steel. You can just scrape just a little bit of that material away. It works very well. I've gotten 95% joints without a whole lot of trouble. It surprises me. I mean, it's a wonderful little device. So you fit your hook. Okay. The next thing you do is when these barrels start coming down, you're gonna want to start fitting the barrels against the breech face. And what we're talking about is an arc again. So you're going to want, it'll start from the bottom up. Bottom will hit first, and then you start working your way up. And again, this is not an absolute perfectly perpendicular, so you really can't use like a surface grinder or anything. You just simply file it in, and you smoke your barrels, and you close the things together. Now, this is not a delicate operation. You're talking about two steel surfaces you're trying to fit up, and you're trying to make a mark. So you want to snap them together. Not real hard. You obviously don't want to create wear, but when you put them together, you give it a little snap. And if you want, you can use a heavy mallet and pop the top of those barrels. You've got to make a high spot in order if you're ever going to clean off your high spots. I personally have tried all sorts of different marking mediums, and I've found smoke works exceptionally well. Smoke really does. It brings out the little high spots. And you're going to be looking for very small areas. Again, wood compresses. Steel is not going to compress. You might sit there and your barrels are almost down, and you can't figure out what's going on. And you look and you look and you look, put a magnifier on, you see this tiny little white spot. And a lot of times when you're doing a refit job, that tiny little white spot, it's not on the outside. It's way down here, right up against the barrel extension. You have to go in there and just take that little bit out. It's down. It's amazing. Absolutely amazing. So, okay, now you've got the hook fit, and your barrels are down on the breech. You've taken out all your locking bolts. You still haven't even gotten to your locking bolts. Next thing is you fit up your locking surfaces, whether they be a barrel extension or a wedge fast system with an underbolt. Then that's the time when you do that type of fitting work. When you get these barrels down, you look at them, you want to look at them up in the light, you'll see light through here. If you look on most of your English guns, you're also going to see some light down in here. That bar is not dead flat. You've got a little gap in there so you can spring when that gun goes off. So your newest Italian guns, they fit the bar and the water table dead flat. So there's no gap in there. Obviously they work, but if you do see a tiny little gap in here between the flat to your barrel and your water table, that's a design feature. So don't get too concerned. If it's a lot of gap, obviously what's happened is that you haven't set your hook down far enough. But you will find a very slight little gap in there, and that's for flex when that thing goes off. Okay. Last thing, let me see, we've got a few more to go yet. You've also taken out your extractor or your ejectors. What you'll find a lot of times is that you might have to fit you put your extractors back in, the barrel all of a sudden doesn't want to block up. Usually it's the bottom surface, or sometimes if you set the barrel back quite a ways, you'll actually have to take quite a bit of surface face off of these extractors because they're going to be sticking out now beyond the reach of those barrels. All right, now your barrels are on the gun. Everything's great, but you still don't have a gun because you don't have a fore-end iron on it. Put your fore-end back on there. You've set your barrels back, so your fore-end's going to be tight. You may have to do a little bit of work where I usually like to cut them to take a little bit of surface off the barrel, off the back of the loop. If you're fitting up brand new sets of barrels, like for example, a man has an ejector Parker shotgun. He wants either another set of barrels, or he has a Damascus barrel gun, and he wants a new set of barrels, and you go and you buy them from the Parker Reproduction people. You get everything all set. Everything's all locked up. You've got your fore-end iron on. You're ready to go. You're ready to get your money from the customer, and you test it. Oops, ejectors don't work. Doesn't cock. What's happened is you've changed the relationships of these surfaces on this barrel, and our relationships can be rather critical. So you've got to go back. You may end up, test your gun. You may end up having to refit your cocking bars so that everything works right. Or you might have to do a little bit of work on your ejectors, or maybe your trigger doesn't function exactly right. It's all interrelated. Okay. What you've got to do, at least what I had to do on an LC Smith anyway, is I took a long aircraft drill, 12-incher, because see, you've got a tang here. You can't get to that hole from here. The tang's in the way. When they build these guns, they take that tang and say, I don't like it there, and they bend it over. And they work on the gun and bend it back, and then they build the gun up. But for us, we can't just bend our tang over. So what I do is I make some bushings that fit in these holes where our cocking bars go, and I spot drill from the top down with a little undersized drill. You're drilling into a rounded surface, and it's a lot of times that drill will wander a little bit, and it's really difficult to get everything right on the money. So what I do is I drill it undersized, come in from the front with a little handy grinder, and I'm very carefully with my files, and I'll open up my hole. It's not a critical dimensioned hole, but you do want to make it look nice. Okay. Now that you've got all that set up, if you're going to be color hardening the action anyway, you leave everything together, put your dowel pins in that lock that hinge pin in place, and you send it off to the color hardener and say, done, until you come back and do last minute fitting when it comes all back together again. If you've got a gun like this Crown Grade that I had some nice color on it, the man didn't want to refinish. Now's the time you have to pull that silly hinge pin out, send it off to the engraver, get it engraved. Then you come back to your shop, you harden it up. And I like drawing the temper on these case hardened parts. I draw them back to a light straw. That way I feel in my own mind that I've got quite a bit of hardness, but I don't have any brittlement. And then very carefully you say a word to the Lord, and you pop it back in there. Hopefully everything's lined up. You pop your dowel pins back in there, you're locked, you file it off, and you're done. So it's real simple. Only $29.95. You do it every day. Okay, that's how you do it on that LC Smith. Any questions? Oh my goodness, yes.
Could you discuss a little bit methods of removing? I mean, you tap out the hinge pin. That sounds really easy, but oftentimes
I forgot to bring my hammer. I'm not strong enough. Okay. I have a 4-pound sledgehammer, and I also have about a 4-pound brass. Yeah. Well, when we say tap, a lot of times on these guns, I apprenticed to a gentleman named Jack Jenkins, an old timer of the old school, and when I first got in there, I'd watch him work on these fine guns, fine double guns. He had a whole series of hammers, and he'd sit there and look at something, and naturally he isn't smashing the gun. He knows how to hit it, and when he's fitting up, he'll look at it and say, well, I want to make a mark. I want that thing to fit just a little bit, and you smack, and it'll pop at one. And you look at him in horror, and you say, and he kind of looks at you and says, well, that's how they made them, and it's right. when they were first fitting them up, boy, when these guns are in the light, boy, those actioners, they give them a smack. So when they set these hinge pins in, they're in there snug. So yes, you are going to have some problems. There might even be a time when you just almost impossible to get that hinge pin out because there's rust and everything else. What I would do is that if I had a situation that was that bad, is I'd call my customer and say, look, you're going to end up with some discoloration on the bar here. And what I do is I take my action, stick it in the freezer. And then I come along and I try to heat up the outside of my action in the knuckle area. The theory is the outside is going to be hotter than the inside where the hinge pin is. And then you're going to break your surfaces apart. And that, so far, for me, has worked every time. I haven't broken anything yet. Yes, Mr. LeFevre, yeah.
Earlier, when you were talking about bringing the barrels down to contact the breech face,
Yes.
do you file solely on the breech face, or do you file both on the back of the barrels and the breech face?
Okay. No, I'm sorry. I solely work on the barrels, not on the breech face. I mean, on the breech face, what I'll do is if there's a lot of pitting on that, and I think I can kind of get away with it, I might file a little bit on that breech face, and then I'm always going to be working on my barrels from then on.
Okay. Everything comes off the barrel.
Yeah, everything comes off my barrels.